Well, howdy folks, we're looking at solving simple exponential and logarithmic equations. This is an essential skill for calculus. Sometimes in the middle of a long calculus problem, you'll have to solve a straightforward logarithmic or exponential equation, and you don't want to get hung up on those steps. So before we dive into the main topic, which is solving these simple exponential and logarithmic equations, let's just do a little bit of review because it's been a minute. If you find any of this challenging, I recommend that you go look at some of the earlier sections that we've had here, introduction to logarithms, exponential log functions, etc., because I'm going to assume a basic familiarity even though we're doing review. Okay, so in this section, I'm asking you to rewrite the following exponential statements as their equivalent logarithmic statements. So the first statement we have is 3 squared is equal to 9. So the equivalent logarithmic statement would be what? Well, we've got the exponent here, 3 squared. The base of that exponent is 3, and so the base of the logarithm remains 3. And then remember how these statements work. We take the log of the resultant to give us the power. So logs return powers of expressions is one way to look at that. Okay. So here we have e cubed is approximately 20, and you can check that in your calculator if you like to see that it's relatively close to 20. And we'd like to give the logarithmic equivalent statement. So remember here, you might think that you should write, well, the log base e of 20 is equal to 3. And if you thought that, you're sort of okay, but we're going to say let's not use log base e. Instead, we go ahead and write the natural log of 20 is equal to 3. We use this ln to stand for log base e. And if that confuses you, you're in good company. I wish we would just write log base e. It would sure save me a world of explaining. Okay. So the last one here is a little bit more general. We've got a to the m is equal to n. And so that is equivalent to saying the log base a of the resultant is equal to the power. And let me put that in parentheses. You don't have to write parentheses, but I think it sets you up for the right mindset because we take the log base a of n, or we take the natural log of 20, or we take the log base 3 of 9. So folks, what I'd like you to do is do your own conversions over here on the right, and I'll see you in a moment. So folks, if you had difficulty with those conversions, please line everything up one for one. Like you can actually use each example that I gave you, line it up one for one, and see, let's see here, in this problem the 3 became the base, the 9 is what I'm taking the log of, the 2 is the result, and do the same work over here. Now what we'd like to do is let's review rewriting logarithmic statements into their equivalent exponential statements. So in this case, we've got the log base 5 of 125 is equal to 3. That's a true statement, that's a true fact, and its equivalent exponential fact is that 5 to the third power is equal to 125. Here we have the natural log of 1 is equal to 0. In fact, by the way, the log base anything of 1 is equal to 0. That's true for any base. That's always true. And that's related to this exponential fact that e to the 0, or in fact any base to the 0th power, is equal to 1. Here we've got this statement, the log 1000 of 3. Sometimes students feel like something's missing here. And just to remind yourself that we would, instead of writing log base 10 of 1000 is equal to 3, we just write log, or log, of 1000 is equal to 3. So here the base 10 is implied. Okay. That's similar to up here where the you would think you would write log base e of 20, and the base e is implied when we write natural log. So let's go ahead and convert this sentence into its equivalent exponential form. And so this gives us, make sure that's an equivalence, that gives us 10 to the third is equal to 1000. Notice, folks, one thing I find really helpful is when you take log base 10 of an expression, it counts the number of place values to the right of the leading place value. So this is the number 1000. It's 1 followed by 3 more places, and the log base 10 of 1000 is 3. That's one of the reasons why it's used so often in the scientific community when you deal with large numbers. The logarithms are a way of counting the number of digits, is one way to think about using them, although there are many other versatile ways to use logarithms. On the right-hand side, folks, I'd like you to again line these up one for one. You've got my statement here. This should be enough to guide you through this statement if you're having trouble. If you do find this difficult, please go back and, like I said, review those earlier pre-works that introduce these topics a little slower and a little more carefully. Okay, folks, that's all for this video. I'll see you in the next one.